When solving for a simple equation, we have to practice the concepts of opposite operation. And so looking at number 1, we have x plus 4 equals 11. What I mean by opposite operation, as complicated as that sounds, is actually really simple. What's the opposite of addition? It's going to be subtraction. And then what do we do to both sides? We subtract 4. And uh, this is the rule you have to follow when dealing with an equal sign. Whatever you do to one side, you have to do to the other. We want to get rid of the 4 because we want to solve for x. That's our whole goal, is to solve for the x variable. And once you subtract the 4 to both sides, you are going to be left with x equals 11 minus 4 is 7, x equals 7. That is the core concepts here that we're going to be practicing. So moving on up with number 2, we have 3x minus 2 equals 4. So what do we do to both sides? We have to add 2 to both sides. There's something different about this problem though. We don't have x, we have 3x. What goes unsaid, what goes unspoken, is there's multiplication happening between the 3 and the x. There's no sign there, there's no symbol here, but we have to assume that it's a multiplication. And so the opposite of multiplication is division. So let me rewrite our equation. We have 3x equals 6. Now I'm going to divide both sides by 3. And the goal, again, is to get the x by itself, canceling out all the other numbers surrounding it. And that's what's going to happen on the left-hand side. The 3's cancel each other. That's why we do the opposite operation, to keep things simple. So we have 6 over 3. Our answer is x equals 2. All right, number 3. We have 3x minus 2 equals 4x minus 9. In this case, this is an important step in combining like terms. We have an x term on both sides of the equal sign, so what do? Don't panic. You want to put them to one side. All right, pick a side. It doesn't have to be the left side all the time. In this case, I see that if I subtract 3x to both sides, we're going to be left over with a positive 1x down below. I'm just going to follow a vertical system here. I'm going to be going down vertically here. So the 3x's cancel. The 4 minus 3x becomes a positive 1x, and I'm going to drop down everything else because I want to take my time here. I just want to take things step by step. So understand that you are allowed to move the entire term 3x. I explained that there is multiplication happening, so a lot of students are going to want to divide by 3, but you don't want to separate anything yet. You don't want to separate the 3 from the x yet, because what you have to do first is combine like terms. Always combine like terms first. Notice how what we did with number 1 and number 2 is we subtracted 4 to both sides. Essentially, we were combining the 4 and the 11. For number 2, we added 2 to both sides. We were combining the 2 and the 4. Those were those like terms. Always do that first before you decide to multiply or divide anything on both sides of the equal sign. All right, moving on with this problem. We have negative 2 equals 1x minus 9. All I have to do is add 9 to both sides. Over here we have positive 7 equals x, or x equals 7. All right, and that is interchangeable. You could change the sides. You could flip them like that. Number 4, quite the doozy for number 4. What I want to show you guys is combine like terms on each side of the equal sign before you start adding and subtracting to both sides, because it could get pretty confusing. If you were to subtract 14, on both sides, where does that minus 14 go to? And do you do it to the 7 and to the negative 3? I want you to eliminate this decision entirely. And you could eliminate that decision by just doing the 7 minus 3. You are allowed to combine the 7 and the negative 3 first, giving us a 4 plus 2x equals 14 minus 3x. The property we utilize here is the commutative property. What happens is we are allowed to switch places with the 2x and the negative 3. So this is what I did in my head. We are allowed to, like I said, switch those places, allowing us to combine the 7 and 3 first. Anyways, that's how we have 4 plus 2x. Now, this looks a lot like question number 3. Let's combine like terms on both sides. I'm going to add 3x to both sides, and then I will subtract 4 on both sides. Okay, so I'm doing the 2 steps in one. We're going to have let's focus on the x values first, 5x, and then the 4's cancel, right? We have 4 minus 4. Now what about 14 minus 4? That's going to leave us with 10. You see, I'm working vertically down. This is typically how I show my work on a piece of paper. I just show the steps that I'm taking below the equation, and I just continue to build down. I just build downward on my notes, in my notes. Remember, we added 3x to both sides, and look, the reason why is because they cancel, the minus 3x plus 3x. So now here we are, we have 5x equals 10, we're looking good. Everything's been taken care of and accounted for. We have to divide both sides by 5. And this is when I want to do it. I want to divide both sides by 5 because all the like terms are combined. So we have x equals 2. Looking good so far. How about number 5? We have some distribution going on. Let's practice our distribution. This negative sign needs to be multiplied to both of the terms inside the parentheses, leaving us with negative 5x minus 6. The 3 needs to be multiplied to both terms on the inside, leaving us with 6x plus 27. All right, now it's the same old, nothing too crazy here. Let's go ahead and do a plus 5x and a minus 27. We're going to get negative 33 equals 11x. Divide both sides by 11, and x equals a negative 3. All right, great job so far, guys. We have some more problems coming up. These next ones are going to be some that you could try on your own, utilizing the steps and notes that I just gave you. Let's do negative 2x plus 8 equals 5x minus 13. Pause the video and try this on your own. All right, so the first step that you want to do is combine like terms. Add 2x, add 2x. And yes, you're allowed to add the entire term to x. Let's do 8 equals 7x minus 13. Then we want to add 13 to both sides, giving us a 21 equals 7x. Divide both sides by 7. X equals 3. All right, good job. Another one. Try this on your own. 2 times x plus 3 equals 4. We have 2x plus 6 equals 4. I distributed the 2. Subtract 6 on both sides. 2x equals negative 2. Divide both sides by 2. X equals negative 1. All right, how about another one? Negative 3x plus 5 minus 4x equals negative, parentheses, x plus 19. So how do we handle that left side, guys? Let's combine the x terms. Negative 3x minus 4x plus 5. I use the commutative property. That's commutative right here. The commutative property to swap those positions of the terms, the 5 and the negative 4x. On the right-hand side, let's distribute that negative sign. Negative x minus 19. All right, let's refocus on the left-hand side. Let's simplify that. Negative 7x plus 5 equals negative x minus 19. I'm going to add x to both sides, actually, giving me a negative 6x. I'm going to subtract 5 on both sides, giving me a negative 24. You see how things work out in our favor. X equals a positive 4. I divided both sides by a negative 6 for that last step. The negative signs will cancel. That's why it's x equals positive 4. All right, great job. I hope that you guys were able to put pencil to paper during this lesson and actually get some good practice in. Watching somebody do something and listening to somebody do something is one thing, but actually trying it on your own is much better. Let's segue into the next video, the advanced level of solving for equations, which will be coming up shortly. Let's do x over 4 equals 10. So we have a fraction here, okay? Fractions can be complicated. This is a simple one to just warm ourselves up. So x over 4, we have a fraction. Fraction is division. The order of operation is division. And what's the opposite of division, guys? It's multiplication. So to cancel out that fraction, we want to multiply both sides by 4. And that's how we get x equals 40. Okay, so you want to multiply to cancel out a fraction. Specifically, you multiply by the denominator. You'll see that as a reoccurring theme. Let's do 3x over 4 equals 6. Do you get rid of the 3 or get rid of the 4 first? My advice is always cancel the fractions. specifically after you combine like terms. As I mentioned earlier, you always want to combine like terms first. Always, always, always. So now that we are in a situation where there's no need to combine anything, there are no like terms that we can combine any further, the next step is to eliminate this fraction by multiplying both sides by 4. All right, so that's going to give us 3x equals 24. And now what? Well, we know that we have 3x, that's multiplication, so we have to do the opposite. We have to divide. We get x equals 8. All right, let's do one more. Let's do an example where we actually don't have all of the like terms combined. So 3x over 4 plus 6 equals 18. So what happens here? You could multiply everything by 4 if you wanted to, like what we've been doing. But that could complicate the numbers. First, combine like terms. Always combine like terms first, guys. It's the easiest way to do these things. All right, and so I hope you can see the 6 and the 18 can be combined. Let's do minus 6, minus 6. All right, they're on opposite sides of the equal sign. That's why we have to do the opposite symbols, the opposite operation. So we have 3x over 4 equals 12. And now we could take off. We could do multiply by 4. So that's mult 4, both sides. 3x equals 48. And now we divide both sides by 3. X equals 16. Okay, great job, guys. Leave any requests below. Be on the lookout for the follow-up video where we cover some more advanced versions of solving for equations, solving for x within equations. Subscribe for more free math help, free math tutoring. I go live every now and then, so turn the notification on so you can join the live sessions. Have a great day. Thanks for supporting.